task 3 is about Newton-Raphson method. So we have to find out the inverse of 0.54 using the Newton-Raphson method. And we have to conduct 2 iterations, choose an appropriate initial guess, and calculate the absolute relative approximate error at the end of the calculation. So here, let's start working with it. The function for the inverse will look something like this one here. So you have the function is 1 over x minus 0.54, and if you want to find out the first derivative of this function, so you have to rewrite the function to see it more nicely visually what's happening here. So let's rewrite the function here. So f of x is equal to x to the power minus 1 minus 0.54. So if you take out the first derivative of this now, you have minus 1 from the power times x to the power minus 1 minus 1, and here you have minus 0.54. So this is equal to actually minus x to the power minus 2, and the constant becomes 0. So that can be written as minus 1 over x squared. So that's the first derivative of the function. And now we can use the Newton-Raphson method formula, which is x of I plus 1 is equal to xi minus f of xi divided by f dash xi. And if you plug in now our function value and our function derivative here, we'll have x of I plus 1 is equal to xi minus our function is 1 over x minus 0.54 divided by minus 1 over x squared. And now if you simplify this, the x squared will go above and multiply. So you will get here xi plus 1 will be xi, and the minus will, with the minus here, will be plus, and then you will have here xi minus 0.54 xi squared. And now simplifying that further, we'll have here xi plus 1 is equal to 2xi minus 0.54 xi squared, right? Now you can write this and use this one here, or you can also use what was given to you in the lecture. So you can directly use what was given to you in the lecture here. So we have in the lecture given to us x of I plus 1, you have your xi common, and you have 2 minus the term, the number of which you have to find the inverse, times xi squared, xi. So this is what was given to you in the class. You can use this directly, you don't have to derive it all. So yeah, instead of the r, we have to replace with 0.54. So that's what your works are directly given, and that's what we have arrived to now using the function. Now let's use it. So first we have to get an initial guess. So let's guess an initial guess of 2 here, and then for the first iteration we have x of 1 is equal to x0, 2 minus 0.54 times x0. So this will be x0 is 2, so 2 minus 0.54 times 2, or let me write the times as a dot so it's easier to see, or you could just keep it multiplied by 2. So this is equal to 1.84. And then now for the second iteration, we'll again use the same formula. So it will be x2 is equal to x1 times 2 minus 0.54 times x1. So you have 1.84 times 2 minus 0.54 times 1.84, and this is equal to 1.852. So here you have the value for x1 and x2. And now let's calculate our absolute relative approximate error, which is EA. So we have the x new, which is 1.852, minus the x old, which is 1.84, divided by x new, which is 1.852, the absolute value of it times 100. So we have a percentage of 0.636% error. That's the end of task 3.